The last type of events we're going to talk about today are inclusive events, which are also known as being not disjoint, or they are called overlapping events. And so they can actually happen at the same time. It's possible for them to happen at the same time. An example would be rolling a 2 on a dice or rolling an even number, because a 2 is an even number, so it's possible for those two events to happen at the same time. Another example would be picking a sock that has red on it or picking a sock that has stripes. But we could have red stripes. So it's possible for these two different events to happen at the same time. And again, this is different than dependent events. It's not like one is affecting the other one, even though they do kind of interrelate with each other. We're only talking about performing one event or one trial, and it's possible for the two different events to happen at the same time on that one trial. So to find the probability of the union of those two inclusive or overlapping events, we would still add the two individual events' probabilities together, but then we're going to have to account for the overlap or take away the intersection of the two events. Okay, so we've still got a union of the two events happening, and we're still talking about either one, A or B, happening, but we're going to have to take away the intersection or the overlap. Okay, so here's an example. Suppose that we roll a dice. What is the probability of rolling a 3 or a number that's less than or equal to 5? Now 3 is less than or equal to 5, so it's possible for these two events to happen at the same time. So if we start with the probability of rolling a 3, that's of course 1 out of 6, because there's only 1 3 on the dice, there's 6 numbers on the dice. Rolling a number less than or equal to 5 would be, 5 out of 6. Okay, because there's 5 numbers less than or equal to 5, and there's 6 numbers total. But then the probability of the intersection of both events occurring at the actual exact same time, if we happen to roll a 3, then we have intersected the two events. We've had them both happen at the same time. And so that could only happen one time out of the 6 numbers on the dice. There's only one way for the two events to happen at the same time. So now I can use that formula, and I could have the probability of my first event plus the probability of my second event, and then taking away the intersection of the two events occurring at the same time. And I'll of course end up with simply 5 over 6. And now you might have known that that was the answer just by looking at the question. What's the probability of rolling a 3 or a number less than or equal to 5? And you could see yourself, well, I could either roll a 1, 2, 3, 4, or 5. Those are the only ways it could happen. And there's 6 different numbers on the dice, so it's just 5 over 6. And that's a great way to check your answer. This formula is very helpful when you start coming up with more abstract ideas and having to come up with an answer to a more difficult question than this one. And so this is a good beginning of understanding how the overlap works, but you can still use the formula to find that answer. Okay, so here's a practice problem. I'd like you to think about it on your own and then unpause the recording once you're ready. So you're going to need to pause it after we read the question. Suppose that you draw a card from a deck. What's the probability of picking a 4 or a black card? So there is an overlap there because there are some 4s that are black. Okay, so pause the recording here, try the problem out on your own, and then check your answer once you're ready. Okay, I'm going to put up the event of picking a 4. So probability of picking a 4 is just 4 out of 52. And of course, half of the deck is black, so 26 out of 52. But there is, looks like we kind of mixed things up. We do have an intersection, though, of 2 black 4s. So that's my intersection of these two events happening at the same time, so I've got to take that away. 4 out of 52 plus 26 out of 52 minus 2 out of 52. And that comes out to 30 minus 2, which is 28 out of 52. And if I simplify that, divide both by 4, I have 7 out of 13 ways of picking either a 4 or a black card out of the deck. Okay, so that's it for inclusive events. If you watch the last video in this playlist, then you'll be able to practice a few more problems.